For our science test, we are needing to understand that the Earth is not heated equally, why that happens, and then what are some things that happen as a result of that unequal heating. So let's first look at why is the Earth heated unequally. So we have learned that our pole is actually tilted 23.5 degrees to the north, right? Otherwise, let me grab the tool here. So right, otherwise the sun would just be the same at every spot. The equator would always receive that amount of sunlight. This area would always receive that, right? Like it would never change, because even if the Earth were on the other side of the sun, it's going to look, right, exactly the same. These would just be opposite here. They're looking exactly the same. This amount of sunlight it's receiving is never changing. So our Earth is tilted 23.5 degrees to the north. So now we can see, right, this equator area is always going to receive sunlight. So it's never going to be out of that sunlight area. But right now we can see the North Pole is getting more direct sunlight. The South Pole is receiving less. So here we would have summer, here we would have winter. But it can't just stay in this place here. It also has to revolve around our sun. So now we're going to get spring and fall, and that sunlight is going to come to our equator and it's going to continue around. Now we can see that the North Pole is pointed away from the sun. So now we have winter, and the South Pole is pointed toward the sun. So now the South Pole is getting more sunlight, and so it will be having summer. And then it's going to come around again. It's going to be over here, and from the sun looking at the Earth, you can see both poles. If you're here, you can only see, right, the sun's coming to the north. Can't really get to the south. This time it can get to both of them, and so here we have spring and fall again, and that sun is going to the equator. So in order for our Earth to receive that unequal heating, it has to have that tilt, and it has to revolve around the sun, not rotate. Rotate is what makes day and night. It's revolving around the sun. It's going around the sun to give those different direct and indirect amounts of sunlight. So we have that indirect sunlight. So what are some things that happen because of that? Well, first of all, like we just showed, we get those seasons. So without that, it would just always be the same. So we get those seasons happening. And then we also discussed how most of that sunlight is going here at the equator. So that's where most of the direct sunlight is going. And so it's heating up the water, it's heating up the air at the equator. So it is causing warm water to move up and out to the poles in both hemispheres. So we can't just say it goes up and down. So right, the warm rises, but it's going to rise to the poles on the north and the south. And then at the poles, it's going to be cold because it's getting that indirect sunlight, and it's going to sink and come back down towards the equator. So it's going to sink down under and come back towards the equator to warm up, where it will go back out to the poles. So in our ocean, we have these different convection cycles happening, little pockets of water that are hot and cold that are circulating about. But this is the general pattern that it's following, is warm out to the poles and then cold coming back to the equator. Now that same thing is also happening in our atmosphere. So the warm air, right, is going to go out, and then it's going to start going out to the poles. And however, because of those unequal heating, once it gets out to like about 30 degrees, kind of starts to lose its energy. It's been giving off that energy, and it's going to actually come back in and sink back down. So these are what we call convection cells. So both of these have to do with convection, water and air cycling around, right? The hot is moving out and up, the cold is coming back down. And so it just keeps happening. So it happens in 3 places on each part of the hemisphere. So three here, 3 here. So we have a total of 6 of these convection cells. So these cells, right? A cell kind of traps something in. I can think of, right, of jail, cell. If I'm working on a table like this is a cell, and it's trapping that information in there. So this is a convection cell. It's kind of, right, trapping that air into the cycle. That's not saying that it can't leave that cell, but it kind of gets stuck there before it passes on to the next one. So that cycle continues. So that hot air, right, goes up towards the poles, and then the cold air sinks back down. It's creating these cycles. So grab my red again. So we've got, let's see, I've got to draw this backwards. So the cold is sinking. Sorry, that was right. Cold is sinking, but I meant to say the hot is rising up towards the poles, and the cold is going to sink back down. And then here we have, right, that goes up towards the North Pole, and from the North Pole comes back down. So it's creating these cycles, 3 on each hemisphere. So we've got warm rising to the South Pole, the cold sinks back in. So we have 3 convection cells on the north and 3 convection cells on the south. So just to recap, right, our Earth is not heated equally. Why? Because our Earth tilts and it revolves around the sun, which gives us indirect and direct amounts of sunlight depending on the relationship of the sun and the Earth. Whichever is pointed toward the sun is going to be having summer. So, right, you can see this, but not back here, then we're going to have summer. If you can see this, but not here, right, summer, winter. If you can see both of them, you're having spring and fall. And no matter what, the equator, whichever one you're in, always gets sunlight. But sometimes one pole or the other can get more or less. So the tilt and revolution of the Earth causes this unequal heating, which gives us seasons, which gives us ocean currents, right? Moving out towards the poles, back in towards the equator, and it also gives us these convection cells in the atmosphere of that air cycling around. So really quick, let's talk about 2 more things. We've got also the jet stream and the Gulf Stream. So they both have to do, right, when I think of stream moving, usually think water, but a stream can also be a stream of air. So this jet stream is a stream of air. You're going to find them in between these convection cells. So that there's this band of air because our Earth is rotating around and it's creating these currents, right? As we move, we kind of catch that wind. So it's creating that circulation. And this air is kind of trapped in between the convection cells. And it wants to go up into this one, but it's not, and then it gets bounced down, and it's just getting bounced up and down between these convection cells. Same thing as everything else. When it's coming up from the equator, it's going to be warmer, and then when it's coming down, it's going to be colder because it's coming from the poles. So it's just these bands of air that are traveling up and down, trying to get into one of those convection cells, kind of. And they're being bounced back and forth, creating these waves. So you've got these strong streams of wind traveling across here. Hot coming from the equator, cold coming from the poles. So we also have the Gulf Stream. So the Gulf Stream is located So let me, draw a very lovely America, that was great. And then we've got some European countries over here. So this Gulf Stream is this stream that comes up from the equator. And right, it's coming from the equator, so it's warm. And then it heads, so it goes like kind of up the, what is that, northeast of the United States, and then heads over to Europe, and it's this warm stream. So it actually makes all of this a lot warmer than it would be otherwise, because it's pretty high up there. If you look at it on a map, some of them are up almost to the polar region. So it means there's some of them are still colder places, but they would be a lot colder without that warm stream of water coming by them. So there's even places like up here where some palm trees grow, right? Palm trees are more native to the equator type of climate and warm California climate. And there's some places up high here where palm trees grow because that warm, moist air is coming off and being blown across that from that warm stream. And if you compare places right across from it, they're going to be cold because they've got cold streams coming down from the poles. So we've got cold here, warm here, even though they're at the same latitude, those ocean currents really affect their climate. Okay, so it's kind of the main ideas. There's a lot of stuff. So if you need to go look up anything in Canvas, make sure you go do that. If there's anything that you're like, I think I need some more information about that. So if you watch this, tell me the difference between a jet stream and the Gulf Stream. So email me, tell me, whatever you want to do. Keep it a secret though, because don't give away your hard-earned money to people that didn't watch the video. So tell me the difference between the jet stream and the Gulf Stream, and I will add in $300 to your account.